Hi everyone, here is 9.5. So hopefully you saw the document that I posted, that it's got all of the word problems we're going to look at here. 9.5 is the applications of quadratic equations. We're going to look at three different types. And so the first part of that handout that I would have printed for you and given you in class, the first thing to fill out are the four solving techniques. And well, you see them there. So the way we started in 9.1, we learned the square root property. Okay, the simplest way to solve a quadratic equation, but it only works in certain circumstances. So we can't use it for everything. But if we notice that we can, it comes in handy. Then the second one we used was completing the square. Now the thing is, completing the square as a solving technique, we're probably really never going to use it because we can always just use the quadratic formula, which we learned in 9.3. But I also noted there is a fourth solving technique to quadratic equations. Sometimes we can solve by factoring. And so if you remember from the review, sometimes you can just solve a quadratic equation if it factors nicely. So this one, that last one's kind of iffy because a lot of the problems we see we can't solve by factoring because they answers involve imaginary numbers or square roots. But it is a solving technique if that works. So I'm really, all I want to do was to list those and say, quadratic formula is really the one that we're going to use heavily. In fact, just about every problem we do here or every problem we do in this section, we're going to use quadratic formula. You still need to know completing the square for your test. Turns out completing the square is a really useful technique in other applications, other circumstances as well. So we definitely need that skill. Um, and okay, I guess yeah, all right. The other two, square root property and factoring, if you happen to see that you might use one of those are really nice techniques and they're faster than the quadratic formula if the situation presents itself. But anyway, okay, let's get to the first example problem. So I'm going to just kind of put this on the screen for a moment. Hopefully you've at least got the PDF of this. I recommend, it may be best to print it, but if you got at least got the PDF and you can kind of watch this video and see that PDF at the same time, I'm just going to go ahead and start this example problem here on the next page where it's not all typed out. Okay, example number 1. It says a triangular sail is to be made such that its height is 1 meter less than 3 times its base. The area will need to be 22 square meters. Find the base and height of the sail. Okay, so kind of give it a first read through, and you're like, oh man, it's got a base and a height, and they tell us how much area we need to create this sail. A great way, or I'd say the only way to start this problem is with a drawing. So I'm just going to draw a simple triangle. Looks like a sail, right? I actually drew a right triangle. Could be any kind of triangle, and I'm going to label the base and the height. So just like that. Okay. Then I'm going to look, okay, so I've got this triangular sail, and it says that its height is 1 meter less than 3 times its base. So if I was to take its base and multiply that out 3 times and take 1 meter less than that, that's the height. And I don't know if I drew this accurately or not, but that's not such a big deal. I need to represent that mathematically. So what can I do? Well, as I read that, the height is those first two words of the beginning of that part. The height is, that tells me to start off with h equals. The height is. Then it says 1 meter less than 3 times the base. How do I represent 1 less than 3 times the base? I should say 3 times the base and then take 1 off of that. That's 1 less than 3 times the base. So I'm going to write that equation along with my drawing. Okay. Then finally it says the area will need to be 22 square meters. And here, you know what is the formula for the area of a triangle? Oh, that's maybe something we talked about in geometry at one point, back at the beginning of the semester. Area of a triangle. Well, maybe you remember that it is 1/2 base times height. And we won't get into the reasons why. That's the area of a triangle. Okay. So far so good. We've got our drawing, and we're kind of getting ourselves in a good position here. We're describing the math with a formula, and we know the formula for the area. Okay, now they said the area is going to be 22 square meters. So I'm going to put a 22 in place of that A. And at the same time, this H, I'm going to substitute 3b minus 1. That whole thing's going to go in for H, and I'm going to get this next statement there. 22 equals 1/2 b times 3b minus 1. Okay, so maybe you've been thinking this whole time, how is this connected to a quadratic equation? And well, it turns out when we simplify this, we're going to have a quadratic. And we can even see, yeah, the b is going to multiply, and we'll have a b squared. Okay, anyway, we've got our equation. Of course, now it's our job to solve this. And we're going to end up using quadratic formula, but it's definitely not in the right it's not in the right shape to apply quadratic formula yet. We need to multiply all this out. We need to gather all the terms to one side, make it equal to 0. Here's what I recommend. It might be tempting to distribute the entire 1/2 b inside here. Don't do that. When you start to involve fractions inside of the quadratic formula, that can get ugly. Instead, multiply both sides by 2. We're almost like multiplying that 2 over here. Well, if I multiply 1/2 by 2, those are going to cancel out. 1/2 times 2 is 1. And so I would much rather think about this. 44 equals b times 3b minus 1. Get rid of that 1/2. Essentially multiply it over to the left side. Okay, and I know we've thought about things like that. I think it's been a good while since we've done things like that. Maybe even way back to the review, and solving some of those inequalities. We might have done some of this sort of stuff. Okay, once we have it in this position, now go ahead and distribute that b. All right, 44 equals 3b squared minus b. And we need to set this thing equal to 0. I'm going to subtract that 44. So I've got 0 equals 3b squared minus b minus 44. And now I can solve it by, really, I've got a few options for my solving techniques, right? I could complete the square, but I really recommend using the quadratic formula. So I'm going to identify my values of a, b, and c. Here a equals 3, b equals -1, c equals -44. Put those all in to my quadratic formula. Of course, my variable here is a b, so I've got b equals, so don't confuse the b's. And simply because we have solved lots of things with the quadratic formula at this point, I'm just going to go ahead and show you how this plays out. First couple steps anyway. Simplifying the negative negative and what's inside the radical and the 2 times 3 gets me those 2 steps. It turns out square root of 529 doesn't seem like that's going to be a pretty number at first, but it turns out that's exactly 23. So just because we've done these a bunch, I'm going to go ahead and, oh, that's the end of my page here. At this point, I want to now write the 2 separate lines. All right, b equals 1 plus 23 over 6, and b equals 1 minus 23 over 6. Excuse me, I sneezed there. Don't know if that came through the microphone or not. And so we end up with our 2 answers for b. B equals 4. And, well, this happened to be a fraction. B equals negative 11 over 3. Okay. Now, what happens in these word problems when we solve a quadratic equation? We're going to end up with 2 answers. But only one of them will answer the question in the context of just what's realistic, I guess, and what is. So even though the mathematics leads us to 2 separate answers, only one of them actually makes sense when you think about the problem. So which one is it? Do you think the answer is b equals 4? Is that what we're looking for? Or is it b equals negative 11 over 3? So if you go back and look at the problem, hey, we're talking about the base of a triangle, right? A sail. Well, it's not going to be negative, right? We can't have a negative length to our sail. So b equals 4 is the thing that we're looking for. And so there I've got it. This is physically impossible. So we can just disregard that answer and we'll take the 4. The base is 4. Now, they also asked for the height. Find the base and height of the sail. Well, if we know the base is 4, how are we going to get the height of the sail? Well, we'll go back to our formula that we had from the beginning. Maybe it'd be more helpful to write that. We said that h equals 3b minus 1. Well, if we're saying that the base is 4, if we plug 4 in, 3 times 4 minus 1, that'll tell us the height. So our base is 4 meters, our height is 11 meters. Okay, I've got one for you guys to try, a similar one. So I know this isn't typed up all nice for you, but there it is. Really, I guess all you need to do really is pause the video and try it out. A rectangular lawn has area 140 square yards. Its width is 6 less than twice its length. What are the length and the width? Okay, we're going to do this one at the beginning of the next video. Try it out. I will see you there.